Assalamu alaikum warahmatullahi wabarakatuh. Today we will be working on practical problems related to projectile motions, starting with a scenario of projectile launched with an angle. So when we say projectile launched with an angle, that means there is an angle between the projected projectile and the horizontal axis. We will ignore air resistance. Now, this motion, when we would like to analyze it, you see the velocity vector first. Velocity, as we see, velocity here in x direction is not changing. Velocity in y direction is changing. So we start with high velocity upward and then keep decreasing. You see the vertical motion, keep decreasing, becomes zero, and then it flips downward. So when we deal with a projectile launched with an angle, we will start with V initial, and V initial, it has two components. So this is the projectile V initial. It has V initial in X direction and V initial in Y direction. V initial in Y direction, it will be upward in Y direction. And this vector keep decreasing its value till it reach zero. So at the maximum height, vertical speed, Vy here is what? Zero at the maximum height, which is delta y maximum. And then what happens? The velocity in y direction flip its direction, horizontal direction always constant, so v in x direction initial will equal v in x direction final. It will be vx always constant, doesn't change. The value of x direction, suppose is 15 meters per second, it will remain 15 meters per second. Now, y direction, we will start with small velocity, and then the velocity keeps increasing because it's falling down in negative direction till it become v final here maximum just before it lands. Now the equation of motion for a projectile, we have x and y component, horizontal and vertical. In horizontal direction we have two kinematic equations, because there is no acceleration in x direction, x direction 0. That's why we end up with two equations. V initial equals V final, and this will equal V because this is V and this is the angle. So in x direction, this side is adjacent to the angle. So adjacent, we learned before in the class, it's always cosine. So this will be VI, the vector VI cosine the angle. This is in x direction. Y direction, it will be sine. Y direction, V initial, and Y direction will be VI sine the angle. In Y direction, we have three equations of motion. Besides, at maximum heights, always we have V final is 0. Time at maximum height is always double the total time. So here at maximum height here, the time here, delta t at, we call it peak or maximum, always have the total time when it lands. Total time means the time when it lands. This one, the time t, delta t total when it lands. When it lands, we don't have displacement, so when it lands, delta y will be 0. And this one, delta y maximum, at delta y maximum, vertical speed is 0. Now let's read the question. The first question that's related to projectile launched with an angle. We have a shell fired from the ground with initial speed 1.7 times 10 to the power 3 meter per second and initial angle 55. Neglect air resistance, find the shell horizontal range, that means I need delta x, and the amount of time the shell in motion, that means I need delta t total. Okay, so Let's solve the question. When you solve it, always try to graph to understand the question. So here we have, and write the given at the same time. So V initial here is 1.7 times 10 to the power 3 meter per second. It launched with an angle, and this angle is 55 degree. Now when we have V initial, always I have V initial in X direction and V initial in Y direction. So we will make this table X for the horizontal motion, Y for the vertical motion. We said horizontal motion, we have only two equations. So the first one, V initial in X direction equal V final X direction, and this will equal V initial cosine the angle. V initial is given, which is 1.7 times 10 to the power 3 cosine 55, and then if you plug these values in the calculator, you should get 975.1 meter per second. It's okay if you write the numbers to digital decimal digit. Now, next we have second equation, which is we're still in X direction. So second equation in X direction, we have delta X. Let's just erase this first. So we have second equation, delta X will equal V initial in X direction times time. V initial 900, we just calculated 975.1, and delta T we don't have it. So we leave this equation and we'll come back to it. Okay, now we'll go to the horizontal direction now. So this one, X, now we'll go Y direction. Y direction, we have three equations. And we will start with the first one, which is V initial in Y direction equals V initial sine the angle. V initial is 1.7 times 10 to the power 3 sine 55, and this is 1392.6 meter per second. Okay. I'm erasing, just follow up with me because I don't have a space I need to erase. Continue here. So delta X here equals 975.5 times delta T. Now, since the question find the horizontal range delta X, and I need to find delta T total. Total time, delta T total, when it lands, delta Y, the height is 0. The projectile, when it lands here, this is delta T total. I don't have height, so the height here is 0. So I'm going to use this information to calculate the time using the second equation. So if I use the second equation now, okay, second equation, I'm still here in Y. Delta Y, we're still here, this is Y and this is X. Delta Y equals V initial in Y direction times time plus half acceleration Y direction times time square. Delta Y, we said when it lands is 0. So this will equal V initial is 1392.6. We've just calculated. If you're following up with me, please take notes. Times delta T minus Acceleration in y direction is negative 9.8. Divided by 2 is 4.9. Delta t squared. Now this is equation, just solve the equation. When you solve the equation, take this to the other side. So it will become negative. So I will have negative 1392.6 delta t equals negative 4.9 delta t square. I just need to erase to keep some room for me, some space for me. Okay. So negative and negative, they cancel out. So I will end up with 1392.6 delta t equals 4.9 delta t square. Here I have delta t and here delta t square. I can cancel delta t here from one of delta t from the other side. So delta t, divide both sides now by 4.9 by 4.9. So delta t will equal 1392.6 divided by 4.9, and we should get 284 seconds. So I found delta t total when it lands. This is delta t total. Now I can find the range delta x when it lands. And this one we'll get it from what? From x, delta x. So remember at the beginning when we graph, when we make a table, we wrote here x and here y. So we have to go to this equation, delta x equals v initial in x direction times delta t, and this should be delta t total when it lands. Delta t when it lands here. This is delta t total when it lands. When it lands, delta y is 0. And here at maximum height, delta y at delta y maximum, always v in y direction always equals what? 0. Always when it lands at the maximum height. Okay. Now just plug the values in. So I will have delta x equals 975.1 times 284. Okay. And you should get 2.77